Consider the dissociation constant data, Kd, for 4 proteins and their respective ligands. Which protein has the highest affinity for its ligand? Okay. So to illustrate the dissociation constant, we have to first of all understand that this is an equilibrium constant. And it's just a specific equilibrium constant for a specific reaction, the dissociation reaction of something. And in this case, it's a protein and some sort of ligand. So I'm going to draw a generic reaction here. It's going to be that the protein bound to its ligand, P and L, dissociate to form P plus L, and with an equilibrium constant of Kd. So if we were to actually write the equilibrium expression here, okay, we'll say that all of these are aqueous reactants. The Kd is going to be equal, of course, to the concentration of P multiplied by the concentration of L divided by the concentration of the intact complex. Okay? So how can we describe affinity of the protein for the ligand using Kd? Well, when we think about it, the higher the affinity of the protein for the ligand, the less dissociation there should be. And so at equilibrium, if this protein has a higher affinity for its ligand compared to another one, its Kd should actually be lower, because at equilibrium there should be more of the intact complex in the denominator than the dissociated products. Okay? So the lower the Kd is, the higher the affinity should be. Right? So we just need to find, right, the lowest affinity protein. But here they're trying to trick us because they're using different concentration units, or rather values, right? It's micromolar versus millimolar. A micromolar is smaller than a millimolar, right? So amongst these, actually, the lowest affinity is going to be the highest Kd value, which is going to be 100 millimolar, okay? And then after that, you have like 10 millimolar and 100 micromolar, but the lowest value here is going to be the 10 micromolar. So protein 2 actually has the highest affinity for its ligand by virtue of having the smallest Kd. So B is the right answer.